appreciate you coming to the podcast. We just want to welcome you here. My name is Andrew Thompson. Just kind of my background, I've developed about 30 plus gigawatts of solar power and Vatan. So we're really excited to have you on here. And I just want to introduce you. This is Vatan Kumar. He is the PV manager at RWE. And for any of you that are unaware, RWE is an industry leader in developing solar. They're a global titan in the renewables area. And part of that is the PV manager, and that's Vatan. And he is the man that is navigating the front lines of massive solar projects and developing and deploying all around the world. So really complex puzzles. And I think today we just kind of want to go through a lot of that and enjoy kind of seeing what your perspective is and how things are changing. And we just want to say we're super happy to have you here and welcome to the podcast.
It's a lot of time consuming. It's a lot of risks that cannot be factored in. We don't have data. And then we don't know what's going to come out. Like we have seen in RWE projects where the soils have really low skin friction, and then the pile lengths get too big, or they even become it also creates logistical issues. Like if you have a 25, 30 feet pile, how do you even get it delivered? It's even hard to get it delivered. So I think electrical you can study in a lab, like you can connect, you can see the electrical currents, and you can see there is some dependency on the field conditions, but it's comparatively less. How do you study all kinds of, you cannot know what kind of soil is there. It's just so much unknown variables that makes it challenging for us.
Yeah, thank you. Yeah, so electrical systems kind of are very repetitive, it sounds like, if I'm understanding you right. And each project has very different soils and also different geography around it that creates different problems for you. So that's an interesting perspective. I'm also just curious, how did you get from power systems to the renewable side? How did you make that transition?
Well, I came to the US to study my electrical power systems with the idea that I wanted to do renewable energy. That's where I was interested in. But then I was thinking there wasn't a course for renewable energy as such. Or I thought at that moment, my thought process was to be a good solar PV engineer, you are doing power generation and you need to know electrical power systems. So I took up electrical power system courses at NC State. So my degree is in electrical power systems engineering, and there was a lot of utility work, and there was a lot of transmission or distribution line understanding or understanding power factor and all the electrical parameters. And I did focus my courses on renewable energy to study more, but I would say more than half of my courses were on electrical power systems. And that helped me when I was applying for jobs, because I had a passion for renewable energy, for solar and battery. And then I was able to get courses from electrical power systems, which creates a whole picture, because renewable is, in the end of the day, an electrical system. You do connect to an electrical grid. So knowing the grid, knowing the electrical is helpful. And then knowing the things about renewable, a big difference between solar and I would say other sources could be in solar, you need to also model the sun. Your input is not something that is given. In a natural gas, you get gas delivered and you put it in, so you can control the input.
Yeah.
In a nuclear, you put the fuel and you control. In solar, you need to wake up and you need to know how much sun is going to come, and that's a whole different modeling. So modeling, the energy modeling in solar is very complex. The uncertainty is higher. So understanding those kind of things that are more related to solar is added value. Then when you study things which are more related to electrical power grid, they are added value. And then there is also a control system variable, and this also applies to structural, how the trackers move, how do you control them, how do you communicate with them. Tomorrow you have an issue, hail has hit your project and you need to move it to a certain degree. You need to know how to move it. Or even if your trackers are not tracking in the right direction. So there is a controls angle to it also, because my bachelor's was electronics and communications. So I was into that part also. So It was, I think, these different things that you need to bring in as an engineer that completes your picture. And I was lucky that there were certain things that were being taught, and there were certain things that I liked, and I combined them together.
Yeah. Wow. That's I love how you kind of keep on being like taking your background and then you're associating how that's helped you out with your like with what you're doing now. Just kind of if you could pick, you gave me about 4 or 5 of them. Like you said, you talked about like your electrical systems, and then also understanding like how the yield of like different types of fields, and like understanding that, like taking what parts of your background um, that you that you brought in the renewables. What has been the most important and most useful for the projects that you're actually building?
That's a tough one, because like every
You have to,
every project can be, yeah, every project is different. And yeah, what background did I bring in? I mean, I can say there was the background of control systems and SCADA when I first came in wasn't quite in demand, because everybody wanted to, because what happened is these plants were implemented everywhere, like, but they also need to like be able to operate and be able to see, and they're huge, like they're spread out in such an area. So being able to communicate with them, being able to read what is happening, and having a system that is able to, and there wasn't, it's getting better today, but at that time they needed engineers who could create a system that could talk to all of them and control and make sure. So I think that initially when I came in, I was interviewing with different companies. Even in RWE for 1 year, I was assigned to do that and create like a controls system, architecture system. So I would say that was very important skill for as an engineer, because that was required. Now in terms of like projects, I could say like identifying civil risks, or identifying the capacity, identifying the buildability of a land is very important from what I've understood. And this is something I've learned over time. Like you over predicting something, like I can do 350 megawatt, but in reality, you might only be able to do 320. Now that puts you in a tough situation, because you signed up for something that your board, like an RWE, there's a board, or a bank, somebody who's assigning, and you got the funding from them for a certain size, believing that you do this. But then the construction company comes who needs to check things, or a design engineer comes, and then they find things, and those you don't. It's better you be on the opposite side, where you predicted 300 and you got 320. You don't want to be in that. And then it's also the GCR, right? Like you might be able to get that size, but really squeezing in. And so I would say the one thing that I would really say is important is the constructability analysis, or being able to identify, looking at the land, what issues are going to come, what is going to increase your cost. And I would say, if you talk about that, there is a part of like one of the things that is really, really hard to analyze is going to be your subsurface again. How do you analyze what kind of soils do you have? Like for example, one of my projects I tried to run on PVCase Prospect, which is a GIS software. It was already built, so I ran over it. It gave me the whole project. It said the bedrock depth was less than 6 feet. So the whole project was not buildable according to it. Then I opened the geotech report, and it showed, I think, 11 or 12 feet, the bedrock depth. So it was much more doable. But what I'm trying to say is, a lot of times, how do you, the data that we have on these free websites like USGS or whatever, the websites that have some free data can be misleading or cannot be used. And then you have that risk, because if I would have gone with that data, it would have said my project is not buildable, because everywhere I'm going to hit or I had to factor that cost. But in reality, that didn't happen. So I think being able to figure out your constructability is a big thing for us as an engineer, and it's really hard to do it on the soil and some of the geotech things.
Wow, cool. From your perspective, when you're doing foundation designs, what has been like what's been the biggest surprise? What when you're doing like a utility scale, what what do you get surprised by when it comes to foundation and pile decisions?
I think, of course, the geotech, if the soil comes really bad, we have had some projects like that can be really tough, because the sizes of the pile goes longer, and then you're looking at other options like annex anchor or APA, I believe that's the ATI's option. So
Yeah.
I think if your soils come bad and you're not able to do it, that's a challenge. And I think frost heave is another thing in Midwest that can push the pile lengths up. That's a challenge. Yeah, I think those kind of challenges, like just figuring out what kind of how many, like what your pile size is going to be, or the uncertainty that it can go really long, or even like figuring out the embedment and reveal can be challenging, especially the embedment lengths. Because how do you figure out the embedment lengths? Like, and then do you want to do multiple embedment lengths, or do you want to do single embedment length? Do you want to do an average for the site, or do you want to do like a distribution? And then the the geotech engineer gives you this zoning, and the zoning sometimes is so hard to understand. I mean, that's and it's like all over the place, and you can't, like, it's like 2A, 2B, 2C, 1A, 1B. There's like so many things going on, and then you're trying to understand what size, what number of my piles are in a certain region and stuff like that. So if you're trying to average, I mean, we have worked with different design engineers. Some design engineers will refuse to do more than one pile reveal and with over the pile load, and that itself puts yourself in a challenge, right? Like, you're trying to be more accurate, and then so that's one. And then the other thing is also, like, I think one thing that is not being factored by the industry, or industry might want to look at, is the snow load. Like, if you have certain areas when you're trying to go towards Midwest, like northern Michigan or maybe areas in Canada, you're gonna have a lot of snow. And how do you factor snow into your pile reveal? Like, there are certain utilities like consumers in their specs, which is publicly available. You can see they have a limit of, if this much pound per feet you have snow, you need to add an extra feet of pile reveal. Like, your clearance need to change. So there is a clearance, there is an embedment. Both have their own challenges that needs to be brought in. And I think understanding them, getting them accurate is can be challenging.
Yeah, getting them accurate. I mean, yeah, that's got to be such a headache, just from the assumptions that where you start and how it diverges from like the assumptions that you made. That's got to be like hard. Like, is that like one of the hardest? How hard does that make you as like the owner, like for the owners, and
I think
from your perspective?
I think there hasn't been much softwares that are able to do it at 10%. It's mostly the 30%, and the 30% takes like a month for them to do it. So that's been a challenge. Some softwares have tried different things. Some have given like one average file. Some have given other things. So I think I think we are moving towards better softwares like PV Farm, Spile, or Plant Predict, which are working towards more detail-oriented, specific. And we are getting towards more and more detail, but the fine tuning is still required. Like, somebody needs to work on these softwares and look at like a result from structural engineer, and then see what is missing and get it tuned. So I think currently it's very hard to do it at 10%. We're getting better. We are making attempts. Like, I've been attempting with like the new softwares, trying to do more of like bring it closer, or like what estimate can we do. I think some things have improved. Like, it's become easier with tracker manufacturer to get number of files has become easier to predict now that you get it. And then the CAD blocks have become easier to put it into the layout software. Those part have become, but I think the next frontier is now pile sizing and pile length. So getting those accurate is going to be, is the one thing that we want to do. And of course, like at 30% design that happens, but how do you do it at sooner at 10%, or how do you get better there? And then to actually know the whole thing, you need to have like an energy estimate, which you have, but you need to make it into an economic model, right? You need to understand how much money is it giving you. But then there's also tax implications, like you get certain money, like there's also like other things like curtailment, there is like energy pricing, there is like congestion, like understanding the grid. So I mean, it's a lot of things getting together. It's a very complex model, and there is no one software that can do it at this moment, at least. So yeah, but it's very hard because there's so many inputs coming from different fields. It's not that easy to optimize and be able to say which is the best scenario.
Yeah, totally. I think as far as like future, like where do you see the industry going? from your perspective, and how like where do you see your team fitting into that?
I think where is the industry going in terms of the renewable
As far as
energy?
like engineering, like engineering problems, like what
Okay.
where do you think the challenges for your younger engineers are going to be? That like maybe like you have, we're kind of gone over a lot of the experiences that you've had and kind of the advancements and changes that you've been in while you've been in the industry, but in the future, like where do you think, like what challenges do you think the younger engineers in the industry will have to deal with?
Yeah. Where do I see the future challenges? I think if we start, if we start with like the first thing, I think transmission is a big deal because like as we are getting more and more solar plants everywhere, the transmission constraints are going to be one challenging thing to understand and to be able to plan and to be able to understand. That's one thing. Like figuring out transmission or like figuring out where you're going to connect or how the cost changes, because your upgrade cost and all that, it's a whole different, that's where the real electrical power engineering comes. It's like if you really want to talk about electrical power engineering, you go there. Like it's like if you want to talk about like real structural engineering, you talk about piles, like pile sizing, torsional load, and PY curves and all that stuff. Anyway, so it's like that understanding if your plant can fit in, because the grid infrastructure is very costly. Like it's like 20, 30, 40 million upgrades. So it can kill a project. So that's number one. I think that's going to be something for students to, or for anybody that comes up into the industry to work, is where are the challenges, where are the good opportunities, where do we fit our plants, and how do we make it work and come up with creative electrical solutions. Now next, after that's one, and then after that I would say like I think we're building projects in areas which are more challenging. Initially, when the solar started, it started mostly in California, in West Texas, in Arizona, flat plains, and not that much slopes and not much of like flooding issues, not much of like
yeah,
I have a project in
all the sites are taken up, huh?
yeah, like I've seen a project in all those sites are taken up and the grid is taken up. The grid is congested. All those because all the solar projects, if they're going to produce the energy at the same time, then you're not going to be able to have space. So you're not going to make much money. So you also need to think about that. So anyway, so that's going to be so that was one. Okay, but now we have moved more into areas in East Coast, in Midwest. Illinois just became the 9th highest solar capacity state last year. The first time I've seen a Midwest state show up in top 10 in the US. So that shows you something. Like Midwest is growing, it's adding more solar capacity. Now, what happens when you go to something like Michigan? Things like glacier melt comes into the picture. Like what is like how do you factor in a glacier melt in your hydrology? So that's a new challenge. And then how do you factor it into your frost heave? And then how much does it add more structural pile? So should you factor in glacier melt or not? Will the glacier melt happen with the worst case scenario when you have the 100-year melt? Like, do you think the 100-year flooding will happen at the same time when the glacier is melting? Like those kind of questions, like you're going into new regions with new soils, with new implications, with so much more snow load, or more frost heave, or like different challenges that are coming in. So that's going to be a challenge to understand. Like how does that work? Like, or you're going into regions in like in Colorado. In Colorado, there is so much more like mountains. There's so much more slopes. So the shading is so much more. So should you like structurally change it? So that's going to be another challenge. Like we did not have that much. We were not building on mountains, but now you are. So you have more slopes. So how do you bend the terrain, or how do you fit in? That's going to be a challenge. So it's like the different geography that you are exploring now, because you are forced to move into areas with different grid. Like, okay, there is a grid, but then the geography is different. Like there is an electrical part, and then there's a mother earth part, right? They both have to meet each other, and you have to understand both sides of it.
Got it. So you speak a lot of the PY curves and a lot of like the foundation analysis. Are there any tools that that you've been able to work with that have helped you make quicker decisions or reduces the uncertainty on your team? Have you?
Yeah.
Do you have any? What tools have you gotten with that that have helped you?
Yeah, I mean, as I'm an electrical engineer, this is not like the most this is not my strong part, but I would also say this is one of the parts that makes me really excited, because as a learner, this really helps me to, like, when I'm able to learn something here, it really helps. Like, it really gets me a new perspective. It opens up my eyes. So I would say, first thing, I'd say that there was a thing about Aspile that we really find very exciting, and Aspile didn't come to me, like, I did not find it by myself. I
Yeah.
was told about it by McCarthy, one of our EPC partners. And then they were exploring, as we were exploring, like, because, like, as we are getting in this estimation, we are trying to get all the estimate components. Like, the first estimation is how much megawatt DC can you get. Then you're trying to figure out how
Yeah.
many tracker blocks can you get. You can get number of tracker blocks. The next part after that is how much grading can you do. Okay, grading is done. How many piles do you have and what size you have? And for that, you need a structural. So I would say S-pile was very exciting in that way, that the interface was very nice. And I haven't seen any other software that does structural calc. And then and reading the geotech was harder, because of course I'm not a PV, so I think that was a harder part. But I think the whole concept of putting it together and being able to run it in a short duration, and then how you have like a business development mode, I think that's been very exciting to us. And we have some internal tools also that our teams are working on. So we evaluate different options. And I think to me, Aspile has been very exciting in that way, that you can get close to being able to do some of the pile design and be able to incorporate the geotech. I think it will add more value if somebody doesn't have a geotech. Can you provide some kind of like reference, like state or something, or this is the best assumption you can do? If somebody could, like, I mean, I think it can be worked more on. But I think it's a great tool for also future engineers, like as a professor or as a teacher. I think it makes me very exciting that I could learn and I could teach and I could introduce. And once somebody gets introduced, once they start putting their feet in, they start thinking more, then they can start to really manipulate the tool. And I think structural, if I can call it, structural engineering has been like a cult, where like, it's exclusive access. It's hard for anybody to actually see what's going on. I think this tool brings it to more mainstream.
Yeah. And that's I love that feedback. And I think you've given a lot of other cases of things that we could develop, and that's like so important for us. And
like, I mean, I could not think about pile sizing before, but now I can think about it. Like, I can think about
I love
it's something that can be done.
Well, the cool thing is that, like, you can just plug it in and you see exactly what effects that number does to everything. And that's what everyone wants to know. And especially it just simplifies it for you, right? So I think that's kind of what you're saying. So I really appreciate that feedback, and we got to get
And
better.
I think,
and
yeah, I was gonna say, and I think the timing is good with like Aspile coming in, because there are softwares that are able to do better blocking and better pile estimation, number of pile estimation, and like interior and exterior pile estimation. But the pile sizing, a software that can also give you pile sizing, will complete the picture.
Yeah, and hopefully, like, similar to like what you're saying with PV case and how it's kind of a software add-in into AutoCAD, you see the future getting handled. And it's exciting that we're part of that future, and that we're going to be we're part of that, and that we can make things simpler for folks like you and owners. And thank you for this feedback. I've really enjoyed this conversation, Vatan. This has been really eye-opening. This has been great. Go ahead.
Yeah, no, thanks for inviting me. And I think in the future, what's happening now is, the good thing I can tell you is, when I first started, in RWE was 2019. Okay, 7 years. We had like one project, and today we have like, I don't know, like 50, 60 projects. I don't know. It's just hard to even keep track of. It's like the number of projects, and the industry has grown so much. And like, I always teach, like one thing that's important to understand is, where do we stand? And we stand really strong at this moment. Like, solar strong's very strong. Like, of all the new capacity that's getting added, 48% is solar. So it's become a norm. It's the cheapest source and everything. So what's going to happen is, when and data centers are coming in, EVs are coming in, The demand is going up.
Mhm.
The market is good for solar. Everybody wants more clean energy. The clean energy regulations are hitting in. So it seems like the world is working towards more clean energy, but before you implement, like anything to be implemented has to be practical, right? Like it has to be able to, so we need to solve those challenges. So it's going to be a lot about having these solutions that can make these projects work where they are stuck, and be able to provide optimization, to provide better pricing, to be able to make them, go through, because you're going to like if your estimates are not accurate, then you can't move fast. And if you can't move, and and also, like, if your estimate is way off, then you're gonna be in for a shocker later, and then it's be hard to justify. So what I'm saying is there's a great opportunity, and in order to capture the opportunity, we need to be accurate. And in order to be accurate, we need to, I call it like the pile sizing is the holy grail of PV designing at this moment, because that's like one of the things to figure out, one of the hardest thing to figure out. So I'm just saying, like, every DC wire sizing is also not easy. That's also like, or it's not the easiest thing to do.
Okay.
So I would say that, and then I'm like, so there are things that we are continuously chasing, and we are trying to get better, and the software companies are working, and different people are working. And I think what I also appreciate is that a software company focusing on one thing and not everything. Like you, like Espile focusing on pile, and then there are like for example, PV do layout. They don't do production modeling. Plant Predict is doing production modeling, but not layout. There were times before where everybody was trying to do everything, and that is very difficult, because then you don't become specialized. And I think it's challenging. So I think focusing on what you're good at and sticking to that is everybody's solving challenges, and then us bringing it together, I think, is a better solution than one person trying to solve everything. Because you want the whole market, but but there are so many challenges that I think it's very difficult for anybody to solve everything together.
And then if everyone in their own wheelhouse can kind of just specialize, and this is what I'm hearing you say, is that you're saying, hey, if everyone kind of works on their own little tool and they optimize that, then we can get into these more challenging sites. We can become faster at getting a preliminary designs. We can get better estimates up front. So I'm right there with you. And I think that the whole industry is trying to push for that. And I think we'll get there. And I think we'll keep solar competitive. And especially when we have conversations like this, where we can kind of get on the front edge of just pushing that. But man, I've really enjoyed talking to you.
Absolute masterclass by you, Vatan Kumar. I really appreciate you having me on today. It's rare that we get such a transparent look into the technical difficulties of what's in the company like RWE. And you did a great deep dive on how pile sizing and how it's valuable for the next generation of engineers, and the complex problems within programming and the programs that you use. It was, and where the industry's headed, and you gave a great roadmap onto where you see things in your perspective on where things are headed. So I just wanted to say thank you for stepping away from your busy job at RWE and spend some time with us. And for our listeners, make sure that you guys follow Vatan's work, and as he continues to push boundaries and solve a lot of difficult problems. I'm Andrew Thompson. Thanks for tuning in.